Hello. In this session, let us see few examples of valves and the symbols that are used to represent that valves. The description is based on the reference book Mechatronics by W. Bolt. Valves and symbols. Let us see how to represent a valve in standard form. Valves are represented typically by a rectangular box like this. In fact, one box shows the position of a valve. Position means if the valve which is meant for passing the fluid, the valve can have two positions. In one position, the flow is shut. In another position, the flow is through. So, one rectangle can be used to represent the flow cut condition. Another rectangle can be used to represent flow permission status. So, rectangle, you have to understand that it is the status of a particular valve. When you see lines attached with the rectangular valve, you have to understand that each line represents connections. That means that valve can have many connections. In this diagram, you can see 1, 2, 3, 4 lines. That means the valve can have 4 connections or 4 ports. Ports means openings. Here there is another an example here. It's a rectangle and an arrow in this direction. Arrow in this direction shows that there is flow permitted only in this direction. That is, in this status there is flow in this direction. There is another example of showing valve here. It's a rectangle, again that's a valve, but inside the valve the flow is shut like this. That means in this status there is no flow. That's the meaning. Here again the same 4 connections are shown on a valve body. Now let us try to understand what is shown here in this standard representation of a valve. This is a valve. We can see that the valve has got how many ports? 4 ports, like 1, 2 here, 3 here, 4 ports. So this is one rectangle. This rectangle shows that this is the one status of this valve. It has got one more rectangle attached with the previous one. That means there is a second status is also there for the valve. That means this particular valve altogether can have 4 ports and 2 positions possible. In one position there is flow in this direction and this direction, and in another position the flow will be from here to here in this direction and flow from here to in this direction. This symbol on left hand side represent the reason for which the status will be changed. That means for changing the status of the valve from this flow condition to this flow condition, this is a reason. Reason means the kind of signal that is given here. This shows that there is an electrical signal or solenoid here shown here. That means an electrical signal is sufficient to switch the position of valve from this status to this status. This shows that there is a spring. That means the changing status, if another signal is given here, it will come back to the original condition against spring load. That's the meaning. So altogether what we understand from this is that it is a 4-port 2-position valve. Now you have to think one more thing from this diagram, that is, in this direction there is flow. You can understand that. Imagine that there is a power supply line here, that is the power supply coming from the power supply unit is coming here, pressurized liquid here, and this line is connected with the reservoir, say. Okay. When there is power supply, the fluid will be going in this direction and go to another line through this port, and the liquid available in this line will be going through this direction and go back to the reservoir. Now when the signal is given to the solenoid, the position will be shifted from here to here. So that what happens is, you have to think that when position shifting means, you have to think that this line is attached with this line and this line is attached with this arrow. Similarly, this arrow line is connected with this line and this is connected with this line in this position. So what happens is, again fluid pressure is coming in this direction like this, in this direction. the fluid flow coming from here will be going through this line, it will go here, it will come here, and it will go in this direction, Whereas the liquid coming from here will be going like this, it will go to this, it will go to this line and go back to the reservoir. Reservoir will be represented like this. For hydraulic liquids, reservoir is the position where the fluid will be collected. For pneumatic devices, reservoir is atmosphere itself. So instead of showing reservoir for pneumatic circuit, we will show only the vent, the triangle and a line. Okay. So just by seeing the symbol, whether it is a triangle and a line or it's a reservoir shown, then by understanding this symbols, you can understand whether it's a hydraulic circuit or a pneumatic circuit. So it's an easy way to understand a hydraulic circuit and a pneumatic circuit is that to check whether vent or reservoir that is shown in the diagram. If the reservoir is shown, then it's a hydraulic circuit. If it is vent that is shown, then it's a pneumatic circuit. So this is the way by which you have to learn it. So switching of position means the line will be connected to other positions. So what we have to understand is that the number of openings, see for valve this position there are 4 openings, 1, 2, 3, 4, 3 and 4 ports here. In this position also there should be 4 ports like 1, 2, 3 and 4. You know why? Because the valve has got 4 ports and the 4 ports are present for any position. So when you show the ports on different states, you have to understand that the number of ports should be equal in all the states or all the positions. Now let us see the symbols that are used to show the valve actuation. In the previous case, we have seen that the valve actuation is done by means of an electrical signal or a solenoid. So we show here there is a solenoid. See, but if the change in position of the valve is by means of a push button, then this is a symbol that will be shown here instead of the solenoid. If the change in status is done by means of a lever, then a lever will be shown here instead of this. Like that, the change in status can be done by means of a roller, by means of a plunger, or by means of spring, can be by means of a solenoid, can be by means of a detent or a holding position, or it can be controlled even by means of a pressure that is taken from another circuit that is called as a pilot pressure, or it can be operated by means of pedal also. You might have seen that pedal operated ramps and all. So if the valve is controlled by means of pedal, you will show a pedal symbol here. So this is the way by which we represent the actuation in a valve. So actuation is shown on either side here as well as here. Let us try to develop a symbol for a simple 2-port, 2-position poppet valve. Now we have seen the functioning of a poppet valve. That is, the poppet valve will have a valve rod and there is a push button and the valve is loaded against a spring. In the normal condition, there is no flow. That is, even if there is liquid coming from this side, because of this position of this valve here, the liquid cannot go and it will escape through this. When you apply force here, the valve will be opened, the liquid from here will be going through this. That was arrangement. So in one condition there is flow shut off and in another condition there is flow. So we are showing that for this valve there are 2 status. In one status there is no flow or a flow is shut, that is represented by this, a rectangle and the shut line, shut symbol. And here the same valve, another position where there is a permission of flow in one direction. So when you combine these two, that represents this valve that is shown here. So in one condition it is shut, in another condition there is flow, and the change in position is happening because of the push button. So push button is shown here. When you release the push button, it will come back to the original shut condition against the spring load. This is the meaning you have to take it from the diagram. So 2-port, 2-position poppet valve is represented by this symbol. There is a symbol for another valve, it is directional valve or non-return valve. That is, it will not permit the flow in reverse direction, it will permit the flow only in one direction, that is a non-return valve or directional valve. Here also there is a valve and is against a spring load. So when there is flow in this direction, the flow will push the ball in this way and an opening will be made, the liquid will come here and will escape through this port. If the pressure is stopped and if, then the fluid from this side, it won't come back to the original line, because when there is flow in this direction, the spring will push the ball against this again. So, the flow in this reverse direction will be shut. So, the symbol of this non-return valve is shown here. This Y line, you can imagine that this Y, this line, these two lines, and this ball, and this line, the direction of flow is sufficient to represent this. That is, this Y, the 0 and this, that represents the symbol. So, in this symbol, when you see that, you understand that there is flow only in this direction and there is no flow in the backward direction. So, it is a directional valve or a non-return valve. Now, let us see how to represent pressure control valves. We know that there are three kinds of pressure control valves: one pressure relief valve, pressure regulating valve, pressure sequence valve. Pressure relief valve means excess pressure will be relieved to the reservoir or atmosphere, so that the pressure in the external circuit will be maintained. So, the representation is, this is a valve body, there is an input line. So, when there is pressure inside the input line, the pressure is taken for lifting a valve. Whenever the pressure is sufficient to bring against the spring load, then the valve will be opened and this flow will be through. That is, this, you can imagine that this direction will be reaching here, so the flow will be through, and this triangle shows that it is an opening to the atmosphere, that is a vent. Vent is shown for pneumatic circuits. So, it is a rectangle and an arrow. The arrow will be coming to the flow direction by taking excess pressure from the inner circuit, and this happens against the spring load. This is a representation of a pressure relief valve, pneumatic type. The case of pressure relief valve for hydraulic type, the only difference is that the excess liquid will be drained back to the reservoir. So, instead of when you show the reservoir, the rest of the things are same. So, there also excess pressure will be taken to lift the valve against the direction of flow, so that the flow will be through, then the excess fluid will be collected back to the reservoir or relieved to the reservoir. In the case of pressure regulating valve, there is a pressure in the external circuit can be regulated by some means, by adjusting a spring or something like that. Arrow mark across a spring, that shows that this spring pressure is like variable, it is variable. The arrow mark shows that it is a variable. Here it is fixed, here it is variable, it is a regulating valve. So, in the regulating valve, again, against the spring load, if the excess air, if it is escaped to the atmosphere through a vent, it is a pressure regulating. If the excess pressure is relieved by allowing the fluid going back to the reservoir, then it is a hydraulic pressure regulating valve. And pressure sequence valve is also having the similar appearance, but you see the vent is not shown, instead the line will be continued. That is, in a pressure sequence valve, what happens is, if there is excess pressure here, the valve will be opened. Once the valve will be opened, that liquid will be going to another circuit where some actuation is happening. So, the pressure in one line, if it is going to a particular limit, then that signal is taken to actuate another one. So, one actuation happens after another one, that means there is a sequence happens. So, this is how a pressure sequencing valve works. So, here it is a regulated pressure, here there is a fixed pressure. For both hydraulic and pneumatic cylinders or pneumatic circuits, pressure sequencing valve symbols are same. Now, let us try to represent a solenoid operated spool valve. Spool valve can be called as a direction control valve. That means it can have flow direction in two ways. In two positions, the flow direction will be varying. That is the meaning. So, this is the schematic diagram for a spool valve, where what you see here, this and this are spools, and the spool is connected with a solenoid here. So, when there is a signal given to the solenoid, this can move the piston against a spring load. So, when there is a signal, you can see that the solenoid pushes the rod, so that the spool will be moving in one direction against the spring load. In one position, liquid from one port will be going through the valve and it will be escaping through another port. In another position, the liquid coming from here will be escaping through this port. So, this is arrangement. So, this can be shown schematically in a standard symbol like this. We know that that valve has got two positions. So, we represent initially by two rectangles here, and in one condition, you see there are three openings here, 1, 2 and 3 openings. So, we will show 3 ports here, 1, 2 and 3 ports here. In one condition there is no flow, in one condition there is flow from this port to this port. Through this port the liquid will be going outside. So, the pressurizing is happening here. So, the liquid coming here will be going through this, it will go through this port. When the signal is given to the solenoid, the position will be changed. So, the pressurized liquid coming here will be coming here, but the flow is shut. So, there is no flow. Now, the liquid available here will reach here, it will go through this, it will go back to the reservoir. That is arrangement. So, when there is solenoid signal given, the flow condition will be switched to this position, second position. If the solenoid control is given, it's withdrawn, what happens is again spring load, the valve will go back to the original situation. So, again spring load it is moving, so the spring symbol is shown here. Since the valve has got 3 ports, 3 openings and 2 positions, we can call it as a 3/2 valve. 3/2, this is a standard method by which industries represent kind of valves. First number represents the number of ports opening and the second number represents the number of positions in the valve. 3/2 stands for 3 port 2 position valves. Now, it is time for you to have a review of the content that you have heard. Can you sketch the standard symbol for a 4/3 solenoid operated DC valve? 4/3 stands for 4 port 3 position solenoid valve. Can you attempt? Can you describe the functioning of a poppet valve? Are you able to describe the functioning of a directional valve? Can you sketch the standard symbol for a pneumatic and hydraulic pressure relief valves? Can you sketch the symbols for pressure regulating and pressure sequence valves? Please review the content and try to answer the question. Thank you.